So I'm really happy to be able to introduce someone that comes from, well, first the largest utility in the United States, but what I would also consider one of the pioneers in the industry, especially in the things that we're talking about today. So very happy to invite Brian Hoff, the Director of Innovation at Exelon Utilities, up to the stage to join me for a quick Q&A.
Thanks, Mike.
Hey, Brian. Thank you for joining us.
Thanks for having
Appreciate
me.
it. So, I call it a revolution. I don't know if you agree or not, but what the heck's going on in this industry and what's driving all of this, what we call transformation in the market?
So, it's first, everybody, thanks for coming and joining with us. You know, I've been working for Exelon 25 years, and again, jokingly, I started when I was 10. But it's a fun industry. I mean, there's a lot of interesting things going on. I'm just going to talk a little bit about the smart home, and then we'll, talk a little bit back from there. And first, I always joke with people, I'm going to give you a little bit of a glimpse inside my house, and hopefully, I think a lot of you guys probably have the same technologies inside your home. Of course, we've all got the Alexa, right? But then you've got all these other voice-enabled devices, and in my house, I've got sensors, my thermostat that I can control with my phone. I've got all my vents that I can control. And you just keep going with all the lighting, the garage door, the cameras. It's just an explosion of devices happen inside the house that are really giving customers more choice. And it's giving them more convenience. And all of a sudden, energy is becoming more and more critical inside of this kind of conversation. Now, what's interesting inside of that first is, and I'll use my Nest again as an example, is the one I happen to have, is what's interesting with that device is now when all of a sudden we want to send a control signal to it that says adjust the thermostat, it automatically does a micro adjustment of the thermostat. My wife doesn't even know. But if I was in the house and I'd walk up and adjust the thing, she would know, hey, something's going on. But as we're going to talk about a lot today, you can aggregate a lot of these loads together and actually have it be meaningful. Because just one individual house isn't meaningful, but when you aggregate a lot of this stuff together, it gives both the convenience from the customer, right, and some of the things that the utility wants. And of course, a lot of fun. I always say I'm a Chicago Bears fan, and I even have my house when the Bears score. Actually, all my lights blink. I play some music inside the home. You got to have some fun with this technology.
Say it like that, the Bears score.
The Bears.
Well, I think obviously, for me, a lot of the value is also shifting, not just the customer experience, but the value is shifting to the edge as well. So talk to us a little bit about how you see this changing the customer experience and
go back one slide,
Sure.
and I'm just going to use this, then we'll talk about the customer.
Okay.
So it's really interesting, everybody, look at this slide, and I think about this probably a little bit too much. If you go back to Thomas Edison 102 years ago, right? We actually started with this electrical system that wasn't a grid. You actually started with individual homes and people having distributed generation. And then they started realizing, wait a second, what if we were to put this stuff together? What if we were to build these big assets? These big assets, it's cheaper to serve, right? And for the last 100 years, that's the model we operate. So when you look at this graph, it really has been this centralized generation plants, these big wires, right? The transmission distribution system that goes down to the consumer. And you can see in this slide, and everybody in our industry jokes about, right? We thought of them as a ratepayer. We didn't think about really as a customer and a customer with choice, right? Because that's the way that the system was designed. As we're moving forward, and then advance to your slide here, is what's really interesting is you now really look at, instead of that meter-centric as we were just talking about in that example, it really is how do you engage the customer and what are the things the customer wants to do? And how do you get the customer to really care about energy, right? And it's not just cost. That's the biggest debate I always have with everybody. They come back and say, well, I really care about affordability. And of course, affordability for energy is a major issue, right? There's a lot of low income that really needs to have that product that we serve at the lowest possible cost. But then when you start moving up the value stack and you start going, well, wait a second, it's not just cost, I really care about reliability. I care that my lights are on at these certain times, I care about resiliency, right? Look at all the storms that are happening across the country, look at the fires that are occurring, look at how we have to return these assets back to be able to provide those customers the power that they want. Then you actually start going to the next level, and people care about what the source is. I, again, grew up on a Midwestern farm, and we actually talk a lot about this on the farm, that people care about organic crops, and they're willing to pay more for that type of thing. Well, people care what how much carbon this energy produces. So it's no longer just saying, I want the cheapest kilowatts. It's actually people care what the source is. So we need to respond, right? So we need to be customer-centric on what our customers are asking us for.
Yeah, I totally agree. So on your point on the grid resiliency and the impact that a distributed grid can have on putting systems back in place. So we've talked before about Puerto Rico and the disaster that happened there. And it wasn't with the fact that Puerto Rico was without power, the power generation was running fine, it was just it couldn't get it to the customer. So talk to me a little bit about how the impact with consumer-owned loads and what you just described as a way for the consumer to get value out of those loads could impact the way we respond to disasters like that.
Yeah, and the first thing I want to level set to, and then I'll answer is, as I continue to look at the future, I do think it's almost like a lot of the IT people think about, are we only going to have centralized data centers? No, we're still going to have things in the big cloud hyperscalers, and we're still going to have data centers and compute at the edge. Energy is the exact same way. You're going to sit here and have these major centralized generation facilities, and you're going to have generation more in the community, and you're going to have generation at the edge, right, at the residential home or around that potential C&I type customer. And I think, and then you have microgrids kind of inside this mix. I think if you set your head around, you're going to continue to have those type of tiers, it really helps you kind of crystallize the way to think about the system. And then you start to realize, how do I have the resiliency at each one of those layers, right? So if you end up still having, some local generation source, and all of a sudden a bunch of snow comes through, and let's just use solar in the example, and the panels are now blocked, somebody's got to go up there and clean the snow, right? Somebody's got to go up there, and again, I joke around with my DirecTV dish. When a lot of snow hits my DirecTV dish, somebody's got to go take the snow off, or my DirecTV doesn't work. It's these same type of things. All of these assets, the problem just moves. So you have to continue thinking about what is the source the energy is coming from, and then again, where is that problem that's going to occur, and how do I fix those things to keep the resiliency?
It's a great segue into the title of our session, which is this concept of the virtual power plant, being able to connect and aggregate those consumer-owned and utility-owned assets into a system that looks and acts like a coal plant. So what is
hopefully a carbon-free plant, but let's keep going ahead.
All right. Well, a more traditional centralized load. So what does Exelon think about this concept of a VP? Is it something that you're pursuing as a growth opportunity, and is it part of your long-range planning?
So I'm going to go back to this whole, if a customer wants it, of course we're going to do it. Again, back to the whole model that we've got to be customer-centric. If a customer, either at a residential level or at a C&I, wants these type of technologies, Exelon's going to provide them, point blank. Then you start to say, now once these customers want these technologies, then you have to ask yourself first, why did they want them, right? Was it, again, resiliency? Was it cost? What is the reason they want them? Because I always say, while we look at the little picture of the home sitting there, there's a lot of multi-tenant families that can't go put solar panels on their house. There's a lot of other renters who that's not an option for them. So we've got to design and continue to design the system that allows for all the different uses and users that use this type of technology. But for the individual who ends up putting a solar panel on their house, we absolutely want them to be able to power their own facility. If they have excess power, have it participate in the grid, and us be able to enable that with them.
So what if their primary motivator is to make money? So again, you gave the example of the tenant in an apartment. I think they can participate in these new community solar programs that are being rolled out. And their motivator, in many cases, their motivator is to make money. Is the market ready to transact that way with a customer and their load?
Yeah, again, I think to your point is the market's currently constructed that it's the large players that get to participate in the markets. And as you continue to look at this, yes, you're going to aggregate various loads, especially at the residential, into a larger mass, and then there will be someone on their behalf doing those broker type transactions for them. I don't really think it's going to be the individual at a small residential load that's going to be the one participating in the market. Now, the other part, again, let's talk about the market for a second. Everybody talks about like, yes, I'm going to go take this, I'm going to put it in. But the same thing that we have as a generator, if you're called upon and you don't act, you get penalties, right? So you've got to be able to say that these assets that I'm going to go put in there, you can make money, but you could also lose. There's some gambling aspects here, especially being in Vegas. All of us should know a little bit about gambling.
Yeah, no, I agree, and I think that a lot of people are talking about this. There's a few projects in the U.S. today that are connecting aggregated loads via something called a virtual power plant,
Yep.
and people are making money. Now, whether they're making money through credits on their bill or whether they're actually getting cash, that's still evolving.
Without a
so,
doubt. And there's multiple technologies, and I think we'll just talk real quick about that is, in like our DC area under Pepco, we've got the collar that you can actually put behind the meter and we can actually bring the loads in.
Yeah.
And so we've got some of the technologies that we're trying to ease the capabilities for the people who've got these type of resources that want to connect it. Then the simplest methodology is net metering, right? Basically, to your point, just roll the meter backwards in that concept. It's really just, again, credit them. Each one of these type of technologies or solutions have drawbacks, because again, now you're not given a really value to the time of that energy, right? Because again, as you're going to show later on, energy is not the same cost throughout the whole day,
Right.
right? Depending on what's happening, there needs to be a little bit of what was the source, what's the time, what's the location, et cetera, of the energy.
And I think it also has to be packaged in a consumer way to drive adoption. I think just trying to sell a solution or drive solutions in the marketplace that are limited just to the energy side, I think you're going to drive, that's going to be limited adoption. I think what we're looking for is something much broader that includes a variety of different services to the customer that also include some of the energy management and energy trading activities that we just talked about. So the title of today's session was around the virtual power plant, and we're going to get into a little bit more detail about what the technology is behind that. So I'm going to start and introduce the concept using this slide to illustrate just the very basic components of a virtual power plant. On the far edge is a distributed network of consumer and utility-owned assets. These can be, to Brian's point, it could be smart thermostats, it could be an inverter in your garage, it can be an inverter at a community solar program, it can be an inverter or inverters managed at a utility solar plant. And it could also include gas-fired generation and nat gas generation at a consumer's home or a C&I business. The concept is, though, to aggregate all that load under a common platform that allows many parties to participate in customer services, and then take that connection and data to the cloud to do analytics with it, to understand how customers are using the energy, to be able to also forecast load in real time, and then ultimately to respond in real time to market price signals that are taken back from the cloud and pushed back through the system to have those devices operate in the way the utility needs them to operate or the market needs them to operate, and of course the way you want them to operate for you to earn money from your participation. So,
Mike, can I pause you for a
Yeah, of course.
question? I'm sitting here thinking through this. I bet you the audience is asking, why Intel?
it's a great question, and I appreciate you asking it. So, to answer, I think that we see this industry moving more towards compute at the edge because of some of the things we just talked about, local decision making at the edge. So if we're going to aggregate a bunch of loads that are intermittent in nature, like rooftop solar, you're going to need the ability to make decisions real time at the edge if you're going to make this look like baseload, which is our ultimate goal. The second is, we think a lot of that new compute and all those new sources of data are going to require some of that data to stay at the edge, just the raw cost of sending data back and forth. So for those reasons, and of course the ability to roll out secure systems, we believe that Intel has a position at the edge in this market, and we think for that reason, that's why we're here in the room today.
Thanks.
So what I'm going to ask next is my colleague Dave Boundy, all the way from Ireland, is going to give us a ride through the technology itself. We're going to go into some of the details and how we're delivering this today. And then I'm going to describe a little bit more about what our program looks like with Amazon.
Thanks, Mike.
Thank you,
Thanks,
Dave.
Brian. So I'm going to talk a bit more about a specific implementation that we've done and also more about the general ecosystem that we're doing. And I suppose as well, building on a little bit about what Mike just said around why is Intel involved in this and what do we bring to the table? Well, at the end of the day, we sell silicon, right? That's the bread and butter of our business. And that's what we still intend to do here. However, we see that, as the guys have already outlined, there's a huge opportunity in terms of the revolution that's occurring, that's underway in the energy industry. So that opportunity is what we're trying to enable an ecosystem to really capitalize on and bring us all in one common direction. So what we're seeing on this slide is how is that ecosystem being built out? At the far left, you've got, or is it the far right? Far left. Yeah, you have the Intel components going into the edge gateways, from drivers to silicon to voice enablement. There's also, and this is part of what we're doing to try and seed this space, is software we've developed around what we call the energy collective optimization software, which is an analytics component that runs both on the edge and in the cloud. And what we're bringing this for is to really show the capability and what can be done, and to work with partners, some of whom are here in the audience today, to build out that overall ecosystem. So we then work with some of those partners being our ODMs, the device manufacturers and suppliers, to bring hardware products to market that can enable the edge compute and control aspects. We then work with the system integrators, both in terms of the software vendors and also Amazon as a key partner to ensure that we can provide the cloud components and also the integration of that in the cloud. And again, as I mentioned, as part of our seeding of this space, we have software that runs in the cloud, and I'll talk more to the specifics of that implementation in a minute. In addition to Amazon providing their cloud infrastructure and marketplace and storefront, they also have their Amazon experts who link a next stage in the requirements for rolling out a solution such as this, which is to go and actually physically install the devices in people's home and overcome that barrier. So really, we're looking at this from the perspective of what are the barriers and how do we overcome them? Who are the partners we need to play with and bring to fore here? And then obviously is how you engage with the customers. So the point of this slide is really just to show how does Intel play in this part, and to say that it's not just about us, it's about a whole ecosystem, a broad ecosystem of partners and we're open to working with many partners to bring this to play, and Amazon as key partners behind it. So we've been talking very much about energy, obviously. I'm just going to step away from that for a little bit and talk about what we're calling the multi-service architecture. This is an open reference architecture that we've defined, which really enables the interoperability of services. Now, we're here talking about and targeting smart homes, but really this could be applicable across many different areas and industries. And at the core of this, there's no great rocket science. It's just about trying to, as I said, find a path and channel that path and bring the ecosystem of players with it. But at the core of it is a common method for those services to talk with one another and to operate together. That runs both at the edge and in the cloud and enables these services to work together. I'll just go into a little bit of an example of actually how this works. So we've got a marketplace where this is a B2B marketplace where a utility can, for example, go and select from a number of different platform providers. So we've got IOTAS as one. Another one is MachineOn. These are provided by partners who we're working with today. So the utility can select that. That will obviously then result in the core platform, that interoperability layer that I talked about, being deployed in their cloud and their gateway infrastructure. Then the utility can select from different services that they want to take. So for example, Informatics is another one of our partners who we're working with who do energy disaggregation at the edge and then provide additional services on top of that. So for example, they're doing aging in place or services and also energy consumption services based on off the core part of this. We then work with the utility might select other services, and we've got one here as an example is another senior living solution from K4 Connect. So these services can be deployed and operated and interoperate with one another. So I showed at the start kind of MachineOn being populated into that. That could be IOTAS, for example, or one of the other partners we're working with there, and those services will work with them. So that's the core of what we're doing here. Now I just want to dig a little bit more into what we're doing in the energy space and how we're seeding that. Now, Intel isn't a company who's going to bring a service to market, but we're working to license the core software that we developed, which we call the Energy Collective Optimization. And you can see here how, in effect, that operates, taking that same model I just shared. We previously talked about those edge devices, and you can see them there. They're communicating to the gateway, they're connected to the gateway, they're managed and operated by the core platform machine on in this case, and that information is shared to the eco platform. That platform is doing analytics to determine what is or to understand the behavior of the users in the home and how they're interacting with services. So for example, heat that was mentioned earlier, or maybe it's your electric vehicle. So just to draw that out a little bit further, you come home at 6 p.m., you plug in your vehicle. Today, what would happen is that would start charging straight away, probably at the worst time that it can for the grid operation. And to Brian's point earlier, maybe it's drawing on coal power. We don't know what power it's drawing on. So what this does is it looks and says, well, actually, we can see your patterns of plug in, your patterns of plug out, and let's just say they plug out at 7 a.m. on a Tuesday morning, and tomorrow's Tuesday, and they've plugged in at 6 p.m. as we expected them to. So we can calculate how much time we have to actually charge it, and as well we can see how long it normally takes to charge that vehicle, let's say 2 hours. So we now have an 11-hour window of flexibility that we can offer back to the grid, or there's two things. We can optimize when we charge it, or we can use it as a service to the grid to say, well, actually, if you want to do a demand response event, here's load that you can use. So this, what we're seeing here is actually what's happening in the cloud. So we've taken that information from the edge, from the gateways, we've aggregated it up, and what you're seeing here is the blue bars are the aggregate load on a 30-minute interval. We can drill down to, say, 5 minutes. It can theoretically go to any granularity you want, but this is looking at a 30-minute interval. It's looking and saying, the blue bars are saying, here's the total load that is available for that period. And then the red line that you see is actually what part of that load is flexible. And what we mean by that is you can shift it out of this window if you like, and it won't impact the user. But what's happening in the background here is there's an optimization engine that's running that has decided when this load should run based on market data. So we can feed into that any financial constraint you like, but including, so for example, ensuring that we're always using green energy for charging. But first and foremost, that we're meeting the end user's requirement for the service. So that's what's happening in the optimization engine. We then, as I mentioned, you can also have a demand response event. This is actually just a screen capture of running a demand response event. So, and obviously this is done through an API. This is just for demonstration, the UI that we have here. But the user can go and specify a time period that they want an event to run on. They can specify the amount of load that they want to run, and then they can obviously get that event scheduled. Once that event is scheduled and then it's approved, and this is just again for a demonstration, we're just showing the approval here. So the event is approved by some other party. Once approved, it will be processed through and it will be actioned at the appropriate time by the system. So it's all autonomous, but one of the key things of what the platform's doing in the background here is it's also understanding what the flexibility is of the devices, as I mentioned, and it's identifying which devices to use that are not going to impact the user. So when we run an event, let's just say we're running an event for 10 megawatts of load, there's 30 megawatts of load available, it will choose the most flexible load to action first so that it doesn't impact the end user. So I'm going to pass you back to Mike and Brian for their engaging Q&A, and thanks very much.
Thanks, Dave. So we have talked a lot about the energy value of a virtual power plant, and we've touched a little bit on the customer value proposition as well. So I wanted to spend a little bit of time talking about how the partnership with Amazon is being formed to solve other obstacles in the way of aggregating this load. So obviously the kind of things that Dave just shown, they're only as valuable as the number of devices that we can connect to that have energy value. So the partnership with Amazon is, in my opinion, one of the strongest channel programs to solve the other big problems, which is around the customer experience and bridging the customer value proposition to the energy value proposition. So I'm going to walk through really kind of a day in the life of a customer in a utility service territory when this program gets rolled out. So the first thing we do is to look through usage profiles to identify and segment the customer base. And then Amazon, Intel, and the utility deploy a utility branded marketing campaign to their customers that ultimately direct them to a landing zone on a website, whether it's the utility's website and marketplace or it's an Amazon.com/Exelon branded marketplace. The customer would go there and find a curated set of products and services, hopefully bundle in a way that meets that customer's needs, all the way from the limited income customers that you talked about before, as well as to customers that can and have interest in the more advanced systems. So once a customer gets there, again, they're going to find the utility's brand, because part of this is, as Brian mentioned earlier, is extending the relationship with the utility closer to the customer. They will pick and choose their bundle, their offer. Some of those offers are going to not look like energy management at all. They'll be aging in place possibly. There may be home automation or home security. But some of them will be very specific energy management, so solar and battery combination, or an EV charger in your garage, or bundled with smart thermostats and smart plugs from different manufacturers. Once you pick and choose your product, your bundle, at that point, when appropriate, we will apply a rebate that's funded by the utility through rate programs that Brian has probably battled through a few times himself. And that helps drive higher adoption because it lowers the entry cost for the customer. There are also options on the marketplace to project finance some of these offers. So if you're going big and you're going rooftop solar and storage and batteries, there is a way to project finance it. And some companies are getting pretty creative about how they're financing some of these solutions with the value from the marketplace. You pick and choose your product and service at the point of purchase, just like you would with an Amazon Prime experience today. You close out your order, and when you close out your order, a scheduling screen will pop, and it allows you to schedule an appointment with the installer to bring the system out into your home and install it. So that's an Amazon employee driving an Amazon truck, certified to do this kind of work based on whatever market we're in. The equipment will then either be brought to you via the Amazon truck, but more likely drop shipped to your home. The Amazon technician will come to your house, set the system up. The systems are all voice enabled, so if there are skills that we've developed specifically with that utility, the installer will train them on that skill, whether it's how to set it up to optimize the price or how to set it up to trade their excess energy, whatever it may be. And then before the technician leaves, they're going to do three things. One, they're going to get the customer's permission to participate in the kind of events that we've been talking about. The second thing they're going to ask is permission to access the data for the specific uses around load forecasting and load shaping. And then the final thing they'll do is activate that system to the cloud, the software that Dave Boundy was just introducing us to, which then becomes immediately available, or the energy value of that solution then becomes immediately available to the utility for whatever purposes. They either want to use it to trade energy, they want to use it to balance the load. There's multiple benefits for the utility once you start aggregating this load. And of course for us, the goal is scale. And this market needs scale if virtual power plants are going to be a viable replacement to traditional assets, and giving utilities, again, the opportunity to engage their customers in a different way. So,
And Mike, I'm just going to interrupt for something here.
Try.
It's interesting. I was on a stage in Chicago one time talking about some of this type of technology, and someone raised their hand and said, Brian, this is great. This is all high-end tech. This all costs a lot of money. How, again, for low income, does this really help? And what we sometimes forget about is simple things like even putting plastic on your windows in some of those climates are simple solutions, right? And even be able to do some of these can help low income. So the one thing that you got to really keep thinking through this is these aren't just toys for rich people or people with middle to high income. We've got to continue to figure out how to have the societal benefits to the lower income people that we serve too.
Yeah, it's a great point. And as a matter of fact, some of the discussions we're having with Baltimore Gas and Electric are crossing over into the Baltimore Smart City Initiative, so that the systems that we deploy there have the ability, for instance, to do food ordering for food deserts in urban areas, et cetera. So I totally agree with you. We got to think about the entire customer base when we roll these out. So that's what we're launching with Amazon. I think today is one of the first official times we have actually come out in public and announced this. We actually had soft launched it in Vienna at European Utility Week a couple weeks ago. So we're looking forward to partnering with Amazon and scaling this out in the next few years. And by the way, this is just a screenshot of one of the marketplaces that we developed today. Sorry, I skipped that one. So we got a little bit of time left, and we also want to make sure we leave time at the end for Q&A. So the next section of our talk is really about where is this going, what's happening, if we come back next year or 2 years from now, what is the impact of pulling customers into the energy equation and creating a more kind of participatory relationship with the customer.
Yeah, and it's interesting, and I'm going to, only people in our industry talk about this slide here with this duck curve, and
yeah, how many people have heard that?
How many people, if you're not in our industry, you're probably looking at that thing saying, what the heck is this thing called a duck curve? But again, I'm going to use this a little bit with some practical examples, again, like that we've been talking about, is, the way, again, this grid was designed is we've got to match when the highest load is put onto the system, we've got to turn on generation sources to match that load, right? And that puts stresses on the entire system. And if you think about it, right, during various parts of the season, when does everybody turn their air conditioner on? When does manufacturing occur? When do a lot of these big power uses happen? That's what makes this duck curve that's on this slide to, kind of keep it really simple. And, I use my wife as, a litmus test, because while I'm Mr. Tech and energy nerd and have fun with all this stuff, she hates this stuff. So, I always balance some of these things we're doing, and I'll use washing your dishes or running the laundry. All of a sudden I said, now you can't turn on the laundry or wash the dishes in the dishwasher because there's high demand right now and time of use is really high. She's like, Brian, then you do the dishes. I mean, we have to remember some of the practical parts of this. Consumers still, to some point, want to have this technology and energy work with them when they want. So they need to be somewhat educated, but you have to be respectful too. Not everyone's going to shut off all their lights, live as a hermit during the duck curve, right? So even me, I joke about my pool pump, right? I've got a pool and I've actually got energy prices that controls my pool pump, but my kids are like, Dad, I want to go out and I want to have the heater on. Are you telling me I can't have the heater on? So this is where this technology has to balance with what consumers want, and we'll get there. So it's, again, for you that don't know the duck curve, that's a little bit of a simple view of it. And again, it's us trying to balance the generation that's happened from, again, the three parts of the grid we're talking about, right? Central, stuff at the kind of, again, community level and at the edge, and how we have that harmony.
Yeah, just to go back into the duck curve, and I agree, it probably needs a little bit better setup than just throwing it up there. But what this slide really is trying to show and illustrate is the load profiles have changed drastically over the last decade. And I can't see the number of the year on the very top at the middle, which was probably 2012. The loads were, the peak period was 2, 3, 4 o'clock in the afternoon, maximum usage across the entire system. But with the introduction of particularly solar energy into the grid, which is producing at that same time, that old peak now is shifted from 3 to 4 o'clock in the afternoon to later in the evening around 5 or 6 or 7, when the traditional large commercial and industrial loads are not at peak, and now the peak happens when folks are at home. They're coming home from work, and their loads now, I think, become more valuable to the grid, which is another, it's another piece of value that I think the customers should get a piece of.
Yeah.
Again, this is California.
It
It's
is.
not every market.
If you look, and if you look globally across, or if you look across the U.S., actually the demand for our product has actually been flat to declining over the last few years too. So that's where some of the next conversations we're going to be having too is we need to have a continued electrification of the various industries. Mm-hmm. If you actually look how clean the stack currently is in energy, it's fairly clean. Now again, we're going to continue to do and add more resources, but that's where now you start looking at electric cars and how do we move that fuel source onto electrification, right? How do you go out and do fork trucks, right? And actually move from a gas-fired fork truck onto electric. So there's a lot of things that we're going to continue to do, and we'll continue to talk about this, is we're going to continue to push, I think, and pull, and people are going to be wanting to put more things onto electricity.
I agree. And this will become, I think, more important.
It's going to be, yes.
So another thing that's going to be important, and I think this is one of your favorite topics, is at the edge of the grid. There exists today smart metering, quote unquote smart metering. And it was built and designed, the last version of, I guess you can debate whether it's smart or not, but last version installed was to create real-time or near real-time access to data, even though it's not collected real-time. To understand better what's happening on the grid, and of course to be able to replace and use it as a revenue meter. So in your opinion, is that existing quote-unquote smart metering system what's needed for the way the industry is emerging and we're starting to, again, interact with customer loads? Or is there a need for what we call smarter metering?
The question, again, and any of us technology people know, we get all hung up on words. We had a dinner conversation last night that Mike's referring to that got kind of fun. What's the definition of smart? What's the definition of real time, right? And you can get into a lot of debates here. I'm going to go back to kind of a simple that we all understand. It ends up being the use case. The use case for what you need to do drives the granularity of the data that you need. So a lot of the smart meter infrastructure that's deployed right now is more of a 15-minute interval meter read data, and then you push that data from the meter into usually the utilities mesh, bring it back into a system, make it available. So a lot of times when other people are now accessing that data, you're anywhere in there from a day old to 2 days old, again, depending on the system. So, but 15-minute interval data serves a lot of different uses. And in this example that's up on the slide, that gateway, I think, is sub-millisecond. There's other solutions that are out there that are sub-millisecond. Not every solution needs sub-millisecond meter read data. Like, that's awful granular and awful particular, but to do some of these solutions, now when we get into elderly monitoring, maybe that is. I could debate right now that there's some things you could do with elderly monitoring that's not sub-millisecond. So we've got to really go through what's the use case. Then we can get into what's the level of granularity of the data to provide that solution that you need.
I agree, it's use case driven, for sure. So the example I'm giving here is a solution that Intel and our partner Infomedics, actually Josh is here from Infomedics, so if anybody has any questions about this solution at the conclusion, you can reach out to him. But in their case, so TEPCO, the largest utility in Japan, I think around 27 million customers, is one of 8 incumbent utilities that are going through what they call liberalization or deregulation of the market, where you can now compete with each other for customers' contracts. So in their case, this solution serves 2 purposes. One, it does collect high velocity, high volume data to be able to look for and create the new services that they want to introduce in this new market as a way to generate new revenue sources and really change themselves into a different type of utility. So I think that was a need they saw. I think the other, which is I think even more interesting, is they're using this as a defense mechanism. So for the delivery of the services into the home, you go through TEPCO's infrastructure, and now the edge of TEPCO's infrastructure is a gateway in the home that's part of the circuit panel. So they've aggressively extended themselves in the middle of this competition to put up a defense strategy. That's something that, I mean,
Here's what's interesting. You go back to I'm going to go back to the customer and what they want. There was a lot of customers who didn't want smart meters. There were some people who really thought that was invasive, and that data would now be up to the utility or who had access to that. And there was a lot of conversations that happened throughout the municipalities and jurisdictions that we serve. As soon as you start opening up and saying, I'm going to go open your breaker box and I'm going to go install this device, I'm going to do sub-millisecond reads, and I'm going to go, that's a whole nother conversation that would have to occur. I think from my belief, again, it would be let's go have that conversation. I don't see it being across the 10 million customers that we serve, that this would be a generic we would just go do. I do think there are probably specific use cases or even a DIY or some professional installer that would go do this. Okay. We've done some testing. There are multiple approaches to get to this level of granularity, but it opens up a whole Pandora's box that you've got to be ready to have that discussion on.
Mm-hmm. Yeah, I agree. We'll get to a little more on the security in a second.
Yes.
So you mentioned this before, the electrification of the transportation system. Not only the impacts it's going to have on the grid and the impacts it's going to have between the utility and the customer, but talk to us a little bit about the opportunities that you see, specifically the project that you launched at Exelon. I think you call it EVZ or EZV?
EZEV.
EZV, okay.
Yeah, so actually one of the things that's actually I've got the pleasure of doing is I get to look across all the different parts of Exelon, and we've got a regulated business and a deregulated, and we've got the ability to try new things that could cross, and sometimes we don't always know exactly where they're going to fit, and again, EZEV is one of those examples for us. As we really started looking across electric vehicles, and we started realizing, again, that's a great new technology that's out there. How do we start educating consumers more about the technology? And what's the role of a competitive energy provider, or what's the role of a regulated utility? And there's multiple roles, but what we kind of did is we stood back and said, let's actually go try a few things. So we actually stood up a web platform called EZEV. It's live right now if anybody wants to go check it out. And what we started to do on this platform is we first went out and worked with the OEMs, and we said, in the OEMs of the cars, and we said, we want to actually have this model because we see a gap in the current dealer infrastructure and dealer networks that they're not really selling these cars. We sent in secret shoppers to actually try to go buy electric cars, and most dealers steered us away and said, here's some other car for you. So we were realizing, again, this dealer model didn't seem to be working appropriately from our perspective. So we stood up this platform. We started doing drive events. We would go to workplaces. We would go to even our own workplaces, and we would educate consumers on that. We actually created this community of other EV drivers that could get together and talk and share their experiences. And as this platform now has continued to grow, we've started to realize we think we have something here. Last year, we enabled over 500 vehicles to be sold on this startup that we've started inside Exelon. And if you think 500, well, that's nothing. There are some dealers in the Mid-Atlantic that we've actually made them the #1 car sale of electric vehicles by leveraging the EZV platform. We actually now have other utilities coming to us saying we would like to white label and brand EZEV as one of our solutions. So now we're actually in early stage discussions with other entities trying to figure out, again, how does EZEV become that national brand for selling electric cars across the U.S. And it's really interesting. That's a role that I would have not have thought a few years ago that we'd be playing. And if you think through it again, we're the perfect people to play. It does make sense when you think about it, and as we've now got some successes with the story. And now that's just the start. We're actually looking at all kinds of other options we can do.
So are you working directly with the EV car manufacturers on this program?
Yes.
And in that relationship you have is the topic of car warranties come up around how plugging in and out of the grid and the grid and trading energy basically from your battery on the grid. Has that been part of your conversation?
Yes. So V2G is definitely. It's interesting. There's all these conceptual that we've talked about for years, and again, that's all this on the inside. We're like V2G, it's going to be the best thing ever, and here's all these great things you can do. But then you get the fundamental problem: there's not enough EVs out there to really even have this be a meaningful conversation. Then you get into the problem that we were talking about. You pull your car into the garage, and actually you have the other problem: people forget to plug it in. Mm-hmm. So it's not that they plugged it in and right away, and all of a sudden they're taking power in the wrong use. They're forgetting to plug it in. Mm-hmm. So you can actually do even some simple services like send them a text: "Hey, you forgot to plug your car in." Those are very useful. How many of you in this audience have forgot to charge your phone, and you're sitting here right now going, "Boy, I wish I would have put my phone in the charger." You have that same problem with these vehicles. So how do we create some easier solutions? And then yes, of course, we can get to V2G, and V2G is a little bit, I'll call it more down the road. There was a lot of people who had started with it, kind of paused, and I think again, you'll see it pick back up.
Yeah, there's a lot of talk about the storage, the impact of mass adoption of batteries, whether it's on the vehicle or in the garage or even utility scale storage. Part of the discussion is that the cost is coming down,
Yep.
It's getting close to grid parity. So what do you see generally in the growth of battery storage, and then more particularly consumer-owned battery storage, again, in the car or outside?
So again, I'll talk to some of my, I'm assuming again we have a lot of techie people in the audience, is if you think about battery storage first and go to a traditional data center and you think about the generator that you had and all the batteries that you installed inside of a data center, that was really only for the transfer load, right? Because again, that's what you're doing for that time of period. So go take a Tesla Powerwall, go take some type of energy storage. The first question I'm going to ask you is how big of the batteries are you going to install in your house for both cost and physical space it's going to take up? And then you're going to sit there and ask the question of, is it 1 hour, 4 hours, 1 day, 7 days, 14 days? How big of a battery system are you going to put? That all has a cost implication, and of course battery technology is coming down. Exxon is doing all kinds of things that we're investing in, working with universities and startups and really trying to enable more energy storage and some of the new breakthrough technologies. So we're all over that, but as today's technology, I'm going to go back to that really practical question. How big of a system, how many days of reliability that do you want to put in your home? And that's going to have a huge cost for you. So again, there's a lot of really good conceptual conversations until you really think through, I need to go put in a battery system that helps me for a week or 3 days. That system starts to become quite big and quite expensive. And that's just not one single Tesla Powerwall hanging on your wall.
Yeah, it's interesting to see where that trend's going to go.
Yeah.
I mean, if you look out, let's say 5 years, in a world where we have seen a wide adoption of these technologies, they're being orchestrated in a way that allows those loads to be part of the energy system. I had three questions
Great.
related to that scenario. So first is, how do you see AI or deep learning or machine learning being an enabling technology to get us to that world 5 years from now, or whatever year from now?
Now you got me sitting there. That's a great question. So again, I will say on some of the AI, we're doing a lot of early stage experimenting with AI too. I actually heard in the keynote, I believe, for here today, that even Amazon was saying some of the AI has not lived up to the hype that we've all thought it was going to. Not saying that it's not going to. I mean, there's a lot of AI that I think is going to definitely apply a lot of good in the future. When I think about today, though, right, I'm stuck with some of the current limitations that it seems that AI is currently still having.
So do you see us using it to automate this load balancing at the edge? You think we'll ever get to a point where the grid itself is self-automated? Each object on the edge of the grid knows the status of the other object and how it needs to react based on changing conditions?
Sure, but I mean, I'll go back to look at the grid today. The grid today is operating pretty darn good with knowing and self-leveling and having automatic reclosers if there's a fault in the system. So of course the systems are going to continue to get better as all of this changes. But right now, again, even without AI, the grid does pretty good at self-managing.
Yep, I agree. Reliability is really high across every utility.
Yeah, when you go back to reliability, yes, there's of course areas that have their own issues. But if you look at a lot of the Exxon utilities, our KD and safety numbers, that's our average age of interruptions, and the frequencies of interruptions have gone down. We're some of the top quartile utilities for providing, reliability of our grid infrastructure.
So follow-on question, in that world, 1, 5, 10, however many years away it is, and all these devices are interacting with the market, where do you see, or do you see blockchain as an enabling technology that will move us faster to that day?
I'm really excited about blockchain. I mean, and we've got some early stage tests going on, but I'm going to go back to some of my early stages on this. Is there's attributes of these commoditized products like energy that people really need to know about, and we need to have smart contracts that trade based upon these attributes. So blockchain is the perfect technology for us to really do that. And it's all of a sudden when you now know that, again, we'll use electricity because we're talking about, or we'll use natural gas as another commodity that my company sells. If you could actually say that this is Pennsylvania gas, or this is from this specific region, there's actually extra value that you can unlock because it all goes into the pipe. So everybody goes, no, it's just gas in the pipe. But if you actually can break apart those attributes, there's markets you can sell and more value you can get by tracking and selling those attributes. So I would think that we're on the very early stages, and if you look at these systems, they're kind of crude. Again, back to this Midwestern farm I grew up on, we had cows, we had grade A milk, but the logs and the forms you filled out were handwritten, and if you look at like gas systems, there's still logs and handwritten things that are occurring inside that system that need digitization. They need blockchain. They need these things to actually make them, what everybody actually thinks they are.
Yeah, I totally agree. Final question, and hopefully we got enough time left for some Q&A at the end. So you're a regulated utility. And
Part of us.
Part of you are. This touches on the edge of regulation today, and I know regulatory bodies are looking at it, and your company in particular has been one of the leaders in changing the way regulators and legislators look at the role of the utility in this new market. And I know part of that is also how is the consumer affected. Part of that is there a security risk now? I know you were talking before about some of your cloud environment has to go through very stringent restrictions to be able to get it in place. So where does regulation and the underlying kind of protecting security for customers and the grid itself fit into the path forward? Is that an obstacle today, and is that an obstacle that we can work around? And what's your company doing about that, or in that area?
Another really good and deep question. What I'll answer here is, regulation is that necessary evil. And I, again, hate to use the word evil, but I'll just say it's a necessity, especially in the businesses that we have. And regulation, it's a good thing. I will agree with you that we need to continue to push the legislation, but they want help. They want to understand how we can enable these new technologies and how they can provide better services. So what I have seen is, as long as you bring the legislation and regulatory bodies along with you, bring in your community and stakeholders into the conversation and have the dialogue, it will go well. If you just come in and say, I'm going to shove it down your throat, that of course is going to have a very bad reaction. So I think in a lot of these things too is we've got to continue to figure out who's the stakeholder group to bring together and get coalitions. Almost like your guys' slide they had about the ecosystem, you really have to map out who's the coalitions that you need to push the legislations forward, that you know that here's the ones who too are not going to be happy with this new solution, how to bring them along so we can move the policies forward. And what I'd say is we have Kathleen Barone is our head of our regulatory arm. Kathleen is very passionate on especially carbon emissions, our 2-degree plan. You can go out and read. Exelon is really committed to what can we do to stop the planet from warming by 2 degrees. What are the actions that we would have to do on both our assets from our own company to protect in case the water levels do rise, if the planet continues to get warmer. And then also what are the things that we can do to reduce our carbon footprint and our emissions from our, both our power plants and also our, just overall operations.
Yeah, you guys are definitely one of the pioneers, a company to watch, and I think to see where this market goes. I think a lot of companies look to Exelon as one of the leaders, so I really do appreciate you coming in and speaking with us today about what you guys are up to.
Thank you.
Hey, we've got about 5 minutes left, so happy to open up the floor for questions. Yes, sir.
Hi, great presentation.
Thank you.
My question is inspired from my days of working on smart grid a couple of years ago during the American Recovery Act. So one of the things, you touched upon it briefly, but I'd like you to elaborate. You mentioned the cost that would involve putting devices like thermostats, smart meters. What is the business model for this? When it comes to, how will consumers actually be paying for this?
Well, and that was the statement that I was making, that if you really look at it, and again, I was not the guy who did the business case for Exelon on this, but I definitely have heard enough of the stories, is there was a lot of the frequency regulation and better response time, and even in some of the states that we had meter readers, reducing that cost for having that staff that had to go out and do that function.
Sure.
Actually showed the benefit for us to go out and do the smart grid investments. So each of those were things that in each of the jurisdictions that we acted, we walked through with our regulatory bodies and said, here's the investment we want to make, here's the benefit that the customers will see. We were audited on those benefits. So then we had to go back and prove that we actually saw those benefits that we actually committed to. And again, fortunately we were, and then that infrastructure was put into place. So that's why I was saying is, with some of these other technologies that you saw, with putting now another device that does a sub-millisecond read, you're not going to push that through and just say, well, hey, everybody, all 10 million customers need that technology, and every ratepayer is going to pay for that.
Sure.
So that's why I was questioning that business case, because you really would have to get through what that value proposition is.
Yeah, sure. Can I just ask one more, if anybody else doesn't have one? Yeah, so now coming to the, the theme of this sort of conference is AI and machine learning. And when you brought up one of these services, and I said, I felt you're also working with one of your partners, where you're doing disaggregation, right? I mean, you have a little AI ML that sits both at the edge as well as on the cloud, and then does disaggregation of your energy consumption. How much did I use for my dishwasher versus heating, cooling, so on. And what that might let you do is actually give you an itemized bill, rather than giving you, oh, you used so many X kilowatt hours this month.
Yeah.
You can say you used X1 for air conditioning, X2 for dishwasher, and now it becomes like a grocery bill. So now at the end of the month, I say, hey man, I spent a lot of money on ice cream, maybe I should cut back on that. You get the drift, right?
Yeah. Yeah.
Are we moving towards such a model? When you asked your question about where do you see AI and ML playing, it's these kinds of problems. Or for example, looking at weather and when renewable will be available, so that your virtual power plant could use the solar as another opportunity, things of that sort.
Yeah, here's my quick response too is, when I got off stage, I'll walk up and I'll show you how much my dishwasher, garbage disposal, garage door opener, I have that device in my house that disaggregates down to sub-millisecond, and it's almost noise. Most people don't want that level of detail. When you really see that, you actually stand back and go, so what? Now that I know that it's my thing's 50 watts, why does that matter? Now, I think there's higher value services that you can put on top of that. It's really not giving them the billing down to that level, that individual hairdryer, right? I got notified one time that I had a spike in my house, and I went up and yelled at my daughter and said, don't use the hairdryer. How well do you think that went with a 16-year-old daughter? She's gonna use the hairdryer. But when you stand back and then you go, okay, what else can I do? Well, I can see my fridge has been running for 2 days consecutively. And I can see my fridge isn't cycling. Therefore, I know my condensers are about to go out. Now I can actually stop my fridge from having spoiled food. That's a value-added service. So that's something that you can now go do and say, I can tell you that you could potentially have spoiled food. A lot higher value than knowing my daughter's hairdryer.
Yeah, both of your questions are related. I think AI, machine learning, edge compute is the bridge to put that value chain back together again. I think the reason why it's struggled to scale is because the value chain is broken. The consumer value proposition hasn't been connected to the utility value proposition. All those pieces haven't been put together again. So the ability to take that data and understand how those loads are impacting the grid, to take that data to create new revenue sources, all the the value chain pieces are starting to come together again, which is one of the reasons why we think this is a great emerging opportunity to participate in.
But again, I just want to keep going on this, like energy efficiency, when we went from a 120 watt light bulb down to a 5, completely changed a lot of this conversation. You don't really care as much anymore about a 5 watt light bulb as you did a 120 or 200 watt light bulb. The energy efficiency of a lot of these new appliances and these devices completely changed some of the story. So there's not as high a value proposition as there used to be because energy efficiency. Sorry.
Yeah, no problem. So we're out of time. Hey, before we go, first of all, thank you very much for your time today. And also, we've got some of the solutions that we've talked about today over at our booth. 2414, I think, is the number. So if you get a chance while you're here, please come by and visit us. We can talk a little bit more in detail about some of these things. So again, thank you very much.
Thanks.